Radium-226 is a common isotope of radium and has a half-life of 1620 years. A sample of 500 grams of radium-226 is given to this context. The first question is, what is the constant of inverse proportionality of the given isotope? So first we have to know what exactly constant of inverse proportionality means. The constant of inverse proportionality is the constant value of the ratio between two inverse proportional quantities. So let me try to illustrate this. Here our two inverse proportional quantities are A, the amount of radium we have, and T, our time in 10 cubed years. So we have an inverse proportion because if one quantity increases, so our time, the other quantity has to decrease. And in fact this happens because A becomes smaller as the time goes on. So not only do we have an inverse proportionality, but we also have a continuous exponential decay. And because of this, we can now use our continuous exponential decay function. So we can write P of t is our time, equals P0. P0 is the initial amount, so the amount that we start with, times E is the Euler's number to the power of k, which is the continuous growth, or in this example the continuous decay rate, times again t, our time. So now we can just put in the values that we have. So our initial amount is 500 grams times E to the power of k, so k is still unknown, times, well, our t, and the only t that we have is the half-life, which is 1620. And so because we have inserted 1620, which is the half-life, and we also have an initial amount of 500, it is only logical to have on the other side half as much as the initial amount. So we should have 250 on the other side. So now we can divide both sides by 500 and get on the other side 250 over 500, which is 1 over 2 equals E to the power of k times 1620. So now we can use the natural logarithm on both sides and get ln of 1 over 2 equals ln of e to the power of k times 1620. ln and e cancel each other out because we have a base of e when we have the natural logarithm. So it is asking us, what do we raise e with to get e to the power of k times 1620? So it is logical that we only have k times 1620 as an option left. So this is the same as ln of 1 over 2. Now we can divide 1620 from both sides and get k equals ln of 1 over 2 over 1620. I typed it in my calculator and got minus 4.27863 times 10 to the power of minus 4. So this is our constant of inverse proportionality. It's our final answer of the first question. So let's take a look at the second question. How many of the 500 grams of radium-226 will be left after 230 years? So this question is relatively easy because it is only asking us to again use our continuous exponential decay function. And now we can use it and put in for our t Well, 230 years. This is equal to our initial value that we start with, so still 500 times e to the power of, well, k, we have k given. This is minus 4.2788683 times 10 to the power of minus 4. And we have to multiply our continuous decay rate by 230. I typed it in my calculator and got 453.1387244, which is approximately 453.14 grams. And this is my final answer to the second question. So if you're given applications like this, remember to read the task carefully and really understand what they want from you. And also don't be afraid making sketches, because oftentimes these work as a support to get to the steps to find the solution. I hope you found this video helpful. Please subscribe if you did and want to see more of this content. If you have any questions or feedback, leave it in the comment section and I'll be glad to answer you. Goodbye, have a wonderful day.